Okay, the Pythagorean identities. All right, these all are associated with, obviously, the Pythagorean theorem that we have sine squared t plus cosine squared t equals 1. And then tangent squared t plus 1 equals secant squared t. And 1 plus cotangent squared t equals cosecant squared t. Now, we're going to use those three are the original ones, but all three of them can be written in three ways. The way you see there, plus two other ways. And you're going to want to have all of them to your availability. Okay? So they've rewritten the ones for sine and cosine. So if I was to subtract cosine squared from each side, then I would get this one here. And if I subtracted sine from both sides, then I would have this one here. And you're going to have to know all of them because there's going to be times when you're going to need them to be able to prove that things are true or to be able to simplify expressions. So the next thing we want to do before we go into the problems here is that we want to take the other two, the one with tangent and cotangent, and we want to rewrite them the two other ways they can be rewritten. Okay. So what's another way I could write the one with tangent squared plus 1 equals secant squared? What's that, Becca? Okay, John, do what? Okay, we can subtract 1. So we could rewrite that one as tangent squared t equals secant squared t minus 1. Okay? That's another way that one can be written. Okay. What's another way we could write it? Well, we subtracted 1. Could we subtract tangent squared? Okay. So 1 is equal to secant squared t minus tangent squared. So that's the way that those two can be rewritten. Okay. Now the other one, 1 plus cotangent squared. Okay. That one can be written two other ways. What's one other way it could be rewritten? Okay, we could subtract 1. So we get cotangent squared equals cosecant squared minus 1. Or we could subtract cotangent and have 1 equals cosecant squared minus cotangent squared. Now there's 9 different identities basically there, okay, that at some point in time you may end up using. So the one thing you're going to want to do, okay, is that before even putting these on your note card, is that you should take a piece of paper and you should start writing the identities on a sheet of paper. And that way you have them all in one spot, easily accessible, that are actually pretty big then, okay, to where you're not writing on your note card like Ben writes normally. Okay? All right, it's not a cut against Ben. All right, so we're going to use the Pythagorean identities. So you might want to, writing these three down too, make sure you have at least the main three, if not all of them. Okay? So let's look at number 3. Okay? And when we're simplifying expressions, we want to look at for a couple of things. One, can I use an identity somewhere? Is there anything I can do to simplify what I see? Is there any factoring that can be done that might be able to help me? And so on. Okay? So when you look at this one here, cotangent squared, sine squared, plus sine squared. Okay? Now, do they have anything in common? Okay, they both have sine squared. So my first step then is going to be to factor out the sine squared. And then I'm left with cotangent squared plus 1. Now, is cotangent squared plus 1, is that an identity? So I go up here, and yes, it is. 1 plus cotangent squared equals cosecant squared. So that means I can rewrite cotangent squared as cosecant squared. Cotangent squared plus 1 is equal to cosecant squared. Now, if we look over here at our reciprocal identities, cosecant squared is equal to 1 over, since cosecant is equal to 1 over sine, well, that applies for squares and cubes. It doesn't matter what the power is, I can use it. So I can rewrite cosecant squared then as 1 over sine squared. And sine squared times 1 over sine squared is equal to 1. Okay. The next identities we're going to look at are the periodicity identities. Okay. And these are just talking about going around the circle. And what was the one thing that we talked about, that when I go around the circle and I stop at the same spot, what do we call those angles? Okay. Coterminal angles. Okay. So all the periodicity identities do is talk about coterminal angles. If I add 2 pi or subtract 2 pi, I end up right at the same spot, right? So if I have sine is positive at a spot, and I go all the way around the circle back to that spot, is sine still positive? Yes, it is. Okay? And that's all that these identities are talking about for the periodicity, is that if I go all the way around the circle, end up back where I started, I have the same thing. Now for tangent, though, because the period of tangent is pi instead of 2 pi, right, then all I have to do is go halfway around for tangent for it to be the same. Okay? I mean, I can go all the way around, they're the same also, but it only means I have to go halfway around. Okay? And these should just make sense to you, that as the period is 2 pi for sine and cosine, if I go all the way around the circle once, end up right back at the same spot. Okay? Or the same with tangent. So I put number 4 here, example 4 from the book up here, finding the value of the sine of 13 pi over 6. And this is similar to the example we did yesterday when we were doing 9 pi over 4. Okay. That 13 pi over 6, we do the sine of 13 pi over 6. So if that's pi over 6 plus 2 pi. So basically we just need to find the sine of pi over 6. So here they want us to find the exact value of cosine of 7 pi over 3. So anytime I have something that's bigger than 2 pi, I'm just going to subtract 2 pi until I get there. Okay, just like we talked about yesterday. So if I take 7 pi over 3 and subtract 2 pi, and a reminder that 2 pi then is the same as what? 6 pi over 3. Okay, it's just a double that. So I'm really just finding the value of cosine of pi over 3, which is equal to 1/2. Okay, negative angle identities. That if we have any real number and construct 2 angles in standard position of measure t and negative t radians as shown, right, that we can see that, right, if we're going in the negative direction, okay, where that means we're going clockwise, right, so we have the cosine of t, and then angle negative t then is in the same spot but in the 4th quadrant, right? So if we looked at the unit circle, here we've got the unit circle. If you look at where pi over 6 is and 11 pi over 6 are, okay, those are both the same distance from 0, right? Okay. If I go counterclockwise, it's a positive pi over 6. But if I go clockwise, that would be negative pi over 6. And you notice that cosine is the same in both places. Sine is 1/2 at positive pi over 6 and negative 1/2 at negative pi over 6. Tangent's positive at pi over 6, negative at negative pi over 6. Right? Let's take another one. Okay. 3 pi over 4. Okay, I got that one circled here. Okay. If we went 3 pi over 4 in the negative direction, that would take us over here to where we're at 5 pi over 4, right? Okay. So at 3 pi over 4, cosine is negative square root of 2 over 2. Cosine is negative square root of 2 over 2. Sine is positive square root of 2 over 2. Sine is negative square root of 2 over 2. Tangent's negative 1. Tangent's 1. So if I take the cosine of a negative angle, it's equal to the cosine of the positive. Okay, we showed 2 examples there where square root of 3 over 2, square root of 3 over 2, they were the same. Negative square root of 2 over 2, negative square root of 2, they're the same. Okay? For sine, the signs changed. Positive 1/2, negative 1/2. Positive square root of 2 over 2, negative square root of 2 over 2. Okay? And for tangent, the signs change. So those are the negative identities that if I take the sine of a negative angle, it's equal to the negative of the sine of the angle. Cosine of a negative angle is equal to cosine of the positive angle. Tangent of negative is equal to the negative of tangent of the angle. So all we have to do then to find these answers is just use that problem then. So here for sine of negative pi over 3, we will do the opposite of the sine of pi over 3. Okay? So the sine of pi over 3 is square root of 3 over 2. The sine of negative pi over 3 would be negative square root of 3 over 2. So we're looking at this. The negative sine of pi over 3. Sine of pi over 3 is positive, so I just make it the opposite. So for cosine then, we want to just find the cosine of pi over 3 is equal to the cosine of negative pi over 3. So that is positive 1/2. So for negative angles, for sine, you find the positive angle, change the sign. For tangent, find the positive angle, change the sign. For cosine, you're just going to use what it is.